Hello, welcome to science class. I am Mr. Laughlin. I will be your science teacher this year. I am so sorry I'm not there yet, but hopefully I will be there very soon. Until then, we will have to do this over the internet with video, sort of teaching and learning. But we're gonna do great. This is a picture of me right here. A couple things about me. I have a family, a wife and a kiddo. He's 4 years old. They're both amazing. We all are so excited to be in Italy and meet y'all. I love to play guitar. I love to rock climb. Um, and I love to read, and I also love science. I got a degree in chemistry, which this class will be focusing on, and I've been teaching for 5 years now. So, today we're going to talk about chemistry. We're going to start with solids, liquids, and gases. Hopefully, you know what these things are on a basic level. You interact with them all day long, right? And a quick thing, I did not make the slideshow. I got it from an online Cambridge IGCSE resource. I did alter it a bit, but I did not make it. I will put some links to where you can find it on ManageBack. But today we're going to talk about these different phases of matter, right? There are three of them. We're going to talk about their distinguishing properties and some other things. So let's get into it. First of all, we want to know the distinguishing properties of these three phases of matter, right? So the things that make them what they are, right? What makes a solid, what makes a liquid, what makes a gas a gas. So we'll go through each one, kind of talk about what makes each thing unique. So, solids. There is a nice, neat little diagram of a solid for you. What are these? Why are there these things in our solid? What do you think? Think about it in your head. Maybe write it down in your notebook. If you don't have that out, you should definitely get that out. What are these things? These things are particles, right? Solids, liquids, and gases are made of smaller bits, and these smaller bits in a solid are all arranged and tightly packed, right? So that's this thing down here. They're all tightly packed together. Like if you've ever been in a train that's super tightly packed and you can't move around, or a bus, this tightly packed organization limits the movement of these particles within the solid. Solids also keep their shape, right? We know this. The chair you are most likely sitting on is not going to suddenly change into an apple or an orange, right? It's going to stay being a chair because solids generally keep their shape. They also have surface boundaries. You don't pass right through the chair you're sitting on. There's a boundary there. You're not going to fall through. And they have a fixed volume, right? So they take up a certain amount of space, and the stuff within that space is not changing. So this is solids, right? Here is a beautiful picture of some solids. This is ice, which is water, right? This is the solid form of water. And you can see all of our distinguishing properties are true. It has a boundary, takes up a certain amount of volume, it's tightly packed. I know you can't see all the particles there, but they are there. Liquids. So the distinguishing properties of liquids, they also have a fixed volume, right? They take up a fixed amount of space. That's why you can measure them in a measuring cup, right? You pour 2 liters of water from one cup into a different cup, it is still 2 liters, even if the shape of the cup is different. Which leads me into this property right here, right? They take the shape of their container. So if you have a liquid in a cup and you pour it on the ground, right? It spreads out everywhere. Their container is much bigger now. It is changing shape, but it is still the same amount of water. They do have a surface boundary, liquids do. You can imagine a pond, right? There is a boundary to that pond. If you throw a rock, it might go into the water, right? But there is a boundary there. And liquids flow as particles slide past one another. So these particles are moving around and they are going around each other. And just like if you threw that rock in, it might cross that boundary and go down to the bottom of the pond, and all these particles would move out of the way, right? They would slide past each other. Here is a picture of a liquid. Again, you can change its shape. It's taking the shape of its container, right? But however much you pour in is the same amount as what's in here. So if you pour, let's say you poured in 50 milliliters, right? You would pour out 50 milliliters and you would have 50 milliliters in your cup. The volume does not change. And you can even see the particles, the things. I know these are bubbles, but it's moving past each other, right? Now, gases. Gases, interestingly, do not have a fixed volume, which sometimes can be strange to think about, right? You pour a liquid out of a cup onto the ground. It starts to spread out, but it still takes up the same amount of space. A gas, that is not true, right? If I have a gas in a cup, like a covered cup, and I open the lid to that cup, those 4 particles of gas will now fill the entire room, right? They take up more room than before, so they do not have a fixed volume. That means they also take the shape of their container, like liquids, but they completely fill the container. The particles are moving around completely free of each other. There's no sliding past. They are bouncing around off the walls, off each other. And they also have no boundary, right? I guess fills the container, so there's no boundary to gases. Here's a picture of a gas. Again, water, right? This is steam or water vapor rising off of this hot pot of water. It is going up into the room. It will spread out and fill this container. So just to review, kind of think about some of those examples. Solids, fixed volume, throw it in a cup. It will not change its shape. It will still take up the same amount of space. It is tightly packed and organized, right? It's not going to change. Maybe you can like smash a solid, right? Apply enough force, you can change it, but if it's just sitting there, it's not going to change into something else. Liquids have a fixed volume but no fixed shape. You can pour them from one container to the next. They will take on a new shape. And this is interesting. Weaker forces of attraction between particles as compared to solids allow the particles to slide past one another, which is what allows liquids to flow. So if we go back here, right, you can imagine that these are all tied together tightly in an organized manner by a force, right? We're going to talk about what that is in a second. And the force here is stronger than it is here with the liquids. There's still an attractive force between these particles, but it's less. So they start to slide past each other instead of being organized and tightly packed. With gases, right, now they are bouncing around all over the place. No fixed volume or shape. They take the shape of their container, and the particles are far away from each other and can move freely. They will bounce off the walls, they will bounce off each other, right? Totally different. So now I want you to think about these questions. So if you don't have your notebook out, get that out, and I would like you to write your answers in that. I'm going to give you a second to think about these. But the first question is, what force or forces are holding solids and liquids together? Right? We talked about there's a force holding them close to each other, the particles close to each other. So think about what that force might be. And then of the three states of matter, which state, so solid, liquid, or gas, has the least amount of that force acting on its particles? So maybe pause the video here. I'm going to be silent for a second. Pause it, think about it, write it down in your notebook, and then I will explain. Okay, so let's talk about this first one. What force or forces are holding solids and liquids together? The force that is holding them together is electromagnetism, the electromagnetic force. You may or may not have heard this word before. It is a combination, right? Electricity, magnetism. Turns out they are part of the same force. They are connected to each other. If it's easier for you right now to just think of it as like magnetism, that's fine. If we go back to our solid, right, these particles are attracted to each other. You could imagine each of them is like a little magnet, and it is attracted to the particles next to it, right? Same is true for the liquids. The attraction is just a little less, so they can move around now. So electromagnetism is the force holding solids and liquids together. Of these three states of matter, which state has the least amount of this electromagnetic force acting on its particles? It is a gas, right? They are moving around, bouncing off of everything. They are not connected to each other, right? In some cases, we actually just completely disregard this force acting on gases because it's so little compared to solids and liquids. And if we were to ask the inverse of this question, which of the three states of matter has the most of this force acting on it, it would be solids, right? They are tightly packed together.